So section 10.3 is going to start to bridge the gap between doing things by hand and doing things with technology. That is, on a computer or a graphing calculator. And it's going to start with the idea of an augmented matrix. Now, an augmented matrix simply means that instead of writing down a system of equations like this, we're going to write down just the coefficients. So you're going to do a little matrix action here, some square brackets, and then everywhere that there's a space, I'm going to write down the corresponding coefficients. So coefficient of x is 1, coefficient of y is 1, z is -1, and then a 1 here. Let's move to the next row. 1, 0, 9, -7. And how about the last one? 0, 9, -1, and 7. Nice. Here we go.
That was easy.
Yeah. Hope for a dozen of those on the exam, right? So now, let's see if we can't do the reverse. And we'll take a look at this one. So this represents an augmented matrix. Let's see if we can't write down the system of equations. Well, I'm going to assume that the variables for this problem are x, y, and z. So what would that be? That'd be x plus 0y. I'm not going to write that. I'll leave a little space here maybe. Plus 0y minus z equals 9. And then the next one is 0x, which I'll skip, y plus 7z equals 5. And the last equation is 0 equals 0. Well, let's see if we can't use our imagination a little bit and figure out what's going on with this system of equations. This is not really much of a 3x3 system of equations because the last one is just all zeros. So what's going on, geometrically speaking, would look like this. You've got two planes that meet along a line. And that's it. We don't have 3 planes, we've got 2. And so you're getting an infinite number of solutions. The nice thing about this problem is it gives us a chance to, practice something we did in the last section, section 10.2, and that is writing this in terms of x, y, and z, writing it as a parametrically defined line. So how's that going to work? Well, if I solve for y, I get y equals -7z plus 5. And if I solve for x, I get x equals z plus 9. Moving the z to the other side, it changes signs, just like the 7 did. 7z. So instead of x, y, and z, I can write z plus 9, and then -7z plus 5, and z. And that's the solution to my system of equations, kind of written parametrically. Now, the fact that I've got an infinite number of solutions here, and they meet along a line, really means that this system of equations is dependent. Be careful that WebAssign doesn't ask for the solution in terms of t. Sometimes they do that. If I needed this in terms of t, it'd be t plus 9, -7t plus 5, and t. So you put in various values for t, and you get out, an ordered triple. Nice. So far, hopefully not too bad. Let's move down to this example here, and maybe I can switch over to this right here and kind of try and blow this up a little bit. I guess it's not working for the moment, so I'll zoom in a little bit this way. And that's about as big as I can get. So we've got an augmented matrix, and they ask you if it's in row echelon form. We haven't got there yet, so let's just take a look at what this augmented matrix says. And it's actually kind of a special one. What's the first row telling me? X equals 9. Well, that's nice. How about the middle row? What does that tell me? Y equals 1 and Z equals 7. So this type of equation, or this type of augmented matrix, is pretty special. It's called a reduced row echelon form. So that's this right here. And we'll talk more about that in a little bit. But what our goal is going to be in working with matrices is if we can manipulate something to look like this, that's great. Because this is really giving you your solution, right? That's telling you that, oh, our solution is 9, 1, and 7. So it's a consistent system of equations. Answering one of the other equations is there. Now, if it was inconsistent, then I would answer inconsistent. But this one is consistent. So nice. Let's come down to the second part of example C here. It's kind of like example B in a little bit of a way. This first row means x plus 0y, which I'll skip, plus z equals 9, and then y plus z equals 1. If I move the z to the other side, I get x equal negative z plus 9, y equals negative z plus 1, and then just z. So that means this is another dependent system. There's infinitely many solutions, and those solutions would take the form of negative z plus 9, negative z plus 1, and z. And likewise, you could write it in terms of t if you wanted to or needed to. Now there's one last example like this, kind of sticking with example C and these instructions. And that's this one down here. So let me kind of squeeze up a little, well, actually give you a glance at this first. And then I'm just going to lay this over top. So our last little system of equations here is this one. And this one gives us something that hopefully is a little bit troubling. X equals 9, y equals 1. Well, what's this last equation saying?
0 equals 7.
0 equals 7. And that should be troubling to you. Because last I checked, 0 doesn't equal 7. So we should get rid of that. What this is telling you, if you have an equation like this that doesn't make sense when you put it into this form, that's telling you that it's an inconsistent system. So that's it. There's no solution. Whatever's happening with this system of equations, there's no solution. So it's one of these three cases or something similar to this over on the left, that the three planes that you're dealing with don't all intersect at one point. You're not getting something like example A over here on the right. So that's it. Now to kind of keep moving along in terms of bridging the gap between doing things by hand and doing things on a calculator, we got to start understanding what the dimensions are of a matrix. So for this, it's always listed in terms of the number of rows by the number of columns. And it's always in that order. And for years, I used to make a joke about my corporate sponsor for this course was RC Cola. Tough to find anymore, although it's been around for over a century. But here you go, RC Cola. The RC stands for Royal Crown. So since 1905, wow.
I've heard of that
Have you?
I've
Uh,
never actually seen it.
I actually had a student order a case of it for my class one time. It was pretty funny. Yeah, we all drink some.
I found it once at a rest stop.
You found it at a rest stop?
Wow.
Did you?
Yeah.
Cool. So the reason I like to use RC is because it's vitally important that you have and understand your dimensions of your matrix are row, then column. Because column and then row is going to give things, it's going to mix things up. So as far as the dimensions of these matrices are concerned, this has 2 rows and 4 columns. So this is a 2 by 4 matrix. That's how you would write it. How about the next one? What are the dimensions of that matrix? Row, then column, right?
3 by 1.
3 by 1. Sometimes this is called a vector matrix or something similar, things like that, or just a vector. But yeah, it's a 3 by 1 matrix. Column vector, that's what I was searching for. Now, let me give you some more official ideas about what a row echelon form is. Row echelon form, this is going to be the part of your augmented matrix, the leading part. It's not going to be the right-hand side, kind of like this. The row echelon form just refers to this little piece right here. So it's that square matrix there. And if everything is 1 on the diagonal and 0 is off the diagonal, then it's in row echelon form. It's in, excuse me, reduced row echelon form. It's in echelon form if you have this kind of an upper triangular matrix. It is, you know, you have a diagonal of numbers here and then zeros below that. This is all you really need for back substitution. But if you get it like this, then wow, that's great. You can just read off your answer, right? Just like we did with this one right here. This was in reduced row echelon form right here. That meant that what we had here was really our solution. So it's kind of cool if you got it like this, then your solution you can just read off. But sometimes there's a lot of work to get it like that. And it's easier just to deal with things in, or to get things into echelon form. Let's take a look at this one. And for this example, it says a matrix is given. Determine if the matrix is in row echelon form. So what you want to look at, this is an augmented matrix. You want to look at this. And as long as you have kind of this main diagonal and zeros below it, then it's in row echelon form. So the answer is yes, it is in row echelon form. But not only do we have a pattern like that, but we also have a pattern like this. We got zeros above and below the main diagonal with ones on that diagonal. So it's also reduced row echelon form. So that's pretty cool. Now, let's see if this is having a little sticking power with you guys. Let's take a look at this one. Is this in row echelon form? Yes or no? So let's kind of zoom in here a little bit and focus just on this little piece right here. Is that in row echelon form? Kind of. So for me, it is. I'm hoping that WebAssign agrees with me, but you got 3 chances if it doesn't. I think it is because it's got, you know, numbers on this main diagonal and then zeros below it. So the fact that this one's a 0, maybe they kind of count that as a bonus. Yeah, I'd say that's in row echelon form. Now, is it in reduced row echelon form? So to follow that up, is it in reduced row echelon form? Echelon, yeah, echelon form. Well, if it was in reduced row echelon form, then you couldn't have anything other than ones on the main diagonal and zeros off of it. But because there's no 1 here, it's not in reduced row echelon form. But it is in row echelon form. So that's nice. Let's try one more, kind of like that. Is this in row echelon form? Is the first question, and is it in reduced row echelon form? That's the follow-up question. So the answer to the first question is yes. And the answer to the second question is also yes. It's both. In fact, what's the solution to this system of equations? Can anyone read that off to me? What's x equal? X equals 6, y equals 3, z equals 9. Beautiful. So if you have something in reduced row echelon form, if you get it in reduced row echelon form, that's great. Now the trick is putting those things in reduced row echelon form. That becomes a lot of work. So let me see if I've got something set up for us here. I hope so. Second matrix. No, it's not in that one. Yeah, here we go. So what we're going to start doing is we're going to start manipulating our matrices to put them in either row echelon form or reduced row echelon form. So that's a nice trick, and you should be able to do simple operations like that one. So for instance, the instructions in example H are to add 2 times row 1 to row 2. So let's take a look at what that would be. Negative 2 times row 1 added to row 2. So negative 2 times row 1, excuse me, 2 times row 1, not negative 2. 2 times row 1 would be negative 10, 14, negative 8, and 8. And I want to add that to 10, negative 4, 1, and negative 20. And so what you're doing is this is a step along the way of putting it in reduced row echelon form. So what will that give me? That give me a 0, 10, negative 7, and negative 12. Beautiful. Now that program that I put on everyone's calculator is really handy here. It's called Row Ops. And let me show you, first of all, how to enter a matrix into your calculator. And then unless you have row ops, you're not going to be able to do the rest. But you can always see me and get row ops. To enter a matrix into your calculator, and we're going to enter our original matrix here, you hit the second key, then the X inverse key. If you look right above there very close, you'll see it says matrix. And because matrix is in blue, you hit the blue button first, which is your second key. The next thing you want to do is you want to edit that. So cursor to the left once or to the right twice to get to the edit menu, and then press enter or type the number 1. It really doesn't matter. Now you got to key in the dimensions of your matrix. So that would be 3 rows and 4 columns. And the nice thing is that you can just type in all the numbers you need, and it'll advance things across every time you press enter. So negative 5, 7, negative 4, 4, 10, negative 4, 1, negative 20, and so on. So you should be able to fill out your matrix just like this. And I've already got mine entered, so I'm not doing that, but as you enter all these numbers, it should cursor you through the matrix. When you're done, when you get down to the very last one, then you can exit this, you can quit. So the way to get out of this is to hit the second key, then the mode key. If you wanted to look back and say, well, gee, did I type in the right matrix? Did I get everything right? Then we're going to go back to the matrix menu. So hit the second key, then the matrix key, and press enter. And it says matrix A. Well, what's in matrix A? Matrix A. Press enter again. Oh, and there it is. So you can see, oh yeah, I got the right thing. So that's nice. Now for those of you who have programmed row ops, there's a little bit more that we can do here, and it's kind of cool. Let's see. Matrix. I just want to check my matrix A. So I'm going to do that on my calculator here because it's not on my TI Smart View. But if you press the program key right here, so third row, middle column, you should see row ops, and press that. And this is cool. This is really cool. It says select a matrix. Well, you need to have put in your matrix ahead of time in order to do this, but we've already done that, so I'll just say, all right, I'll type the number 1 or press enter. And it says, is this the one you want? Yeah, that's the one I want. And then it says, well, what do you want to do? Well, I want to do what we just did. I want to multiply row 1 by 2 and add it to row 2, or row 1 by 2 and add it to row 2. So the command for that is the fourth one down. It's multiply row add. So I'll press the number 4. And it says, well, what row do you want to multiply? I want to multiply row 1. By what? By 2. And add it to what row? Add it to row 2. Now, I should get something like this. Let's hope I do. And bam. Notice that it replaced my row 2 by that number. But there's other things I can do. It's really, really wonderful. So for instance, how about if we swap row 1 and row 3? I prefer to have a 1 or a -1 in the upper left-hand corner. So let's swap those two. So if you press enter and say, all right, this time I want to do a row swap. So I'll do a 1. I'll swap row 1 with row 3. Oh, that looks a little bit better. And if I wanted to continue with this, I would continue to put this in row echelon form, which would mean getting a 0 here and eventually a 0 here. So to get a 0 here, what would I multiply the first row by and add to the third row? What can I multiply this by so that when I add it here, I got a 0? Well, the answer would be -5. So I'll go back to multiply row add, which is the fourth button. Multiply row 1 by -5, add to row 3, and bam, and so on. And so I want to keep doing this until I get it in reduced row echelon form, or row echelon form. I'm not going to go all the way down to reduced row echelon form. That's kind of a pain. So it's a convenient program to have. It really, really is. And If you catch up to me at some point, I'll be more than happy to help put that on your calculator. All right, let's try another one. Let's try this one. So I guess I'm gonna have to quit this. So if you press enter and then quit, I can back out. You gotta press quit twice, and you can see, yeah, something that might tell you that yours truly had a small hand in writing this.
I
But
was about to ask, did you make this? That's really cool.
So let's put this into our calculator, this one. And what we're going to do is we're going to get this in the form of an echelon matrix. We want it in this form. So basically I want to get zeros here, here, and here. And the order that you want to do it is 1, 2, and 3. Oops. You want to get zeros in here in that order. So let's see if we can do that. And I'm going to do it here. So let me put that in my calculator. So we're going to go back to second and then matrix. And I'm going to put this one in matrix B. So go over to edit first and then slide down and select matrix B. So go to the edit menu first and then pick, it doesn't matter what matrix you pick. You can pick A through E. What's the dimensions of this matrix? Remember RC Cola. 3 rows, 4 columns. So there you go. 3 by 4. And now we're going to type in all these values. 3, 1, -3, 4, 3, 3, 1, 11, 6, -4, -1, 7. All right, so I got that done. If I wanted to look at it, I'll hit the second key and then the matrix key, and then go down to B and press enter. It's not a bad idea just to look back and make sure you've got the right matrix. And we do. At least I think we do. Yeah. Now, I'm going to rely on matrix, or I'm going to rely on row ops to do all this. You don't have to. In fact, sometimes what I have people do on an exam, if they're using this, is just write down the list of commands that we're going to do. If I want to get zeros here, here, and here in that order, 1, 2, and 3, I'm going to start by getting a 0 here and then a 0 here. So let's put those, let's run program row ops. What's it going to take to get a 0 here? What am I going to multiply by and what I'm going to add to?
You can multiply the top one by
-1 times row 1 added to row 2. Perfect. So for me, I'm going to select matrix B. Maybe you put yours in matrix A. That's fine. But this is program row ops. That's the right matrix, so we're in good shape. And we're going to do just that. We're going to multiply by a row and then add it to another row. So select the number 4, multiply row 1 by -1 and add it to row 2. Nice. And I get this matrix. Well, let's do the same thing to get rid of the 6 down here. So for that second operation, I'm going to take -2 times row 1 and add it to row 3. So I'll press enter here to get back to my menu. And then select option 4, multiply row 1 by -2 and add to row 3. And bam, looking better, all right? So I got the first two done. I got zeros here and here. And now I need one more. And that is multiply row 2 by something and add it down here so I get a 0 where that -6 is. What am I going to do for that last one? What do I need to multiply this by so I can cancel out that 6 there? Thank you. 3 times row 2 added to row 3. So let's do that. So that's the fourth command again. Multiply row 2 by 3 and add it to row 3. And wow, beautiful. So let's take a look at what I got. Now, it's not pretty. I'm kind of wondering why, but I ended up with 3, 1, -3, 4, 0, 2, 4, 7, 0, 0, 17, and 20. That's the matrix I ended up with. This is perfect for solving by back substitution, except one thing. We're not going to get a nice friendly number down here. Yeah. But this is our augmented matrix. So let's see what system of equations this represents. This represents 3x plus y minus 3z equals 4. 2y plus 4z equals 7. And 17z equals 20. So it's this last one that wet the bed, because it's not going to work out nice. Yeah. But you can solve here, right? In fact, let's at least get z. What's z equal? No, it'd be 20 divided by 17. And then once you know what z is, you take the value for z and plug it in here, and then you can get your value for y. Because the only other unknown at that point would be y. And then once you know those two, you plug it back in here, and you've got your value for x. So it's great when you get it in this row echelon form. And that's something that I might ask you to do next week, is get it in that form. Show me the operations it takes to get it in that form. And I'd give you something simpler than this. Okay. How are we looking on that one? Let's see. Determine whether the system of equations is inconsistent or dependent. So let's take a look at one last system of equations here and see what we can come up with. Now, if you noticed, one of the things that I could do is I could do a row swap. So I could swap. It's generally nice to have the variable in the upper left-hand corner of your system to have a coefficient of 1 or -1. So you could either swap right now and say, all right, well, we'll start out with x plus 3z equals 2, and 2x minus 3y minus 9z equals -5. You could start out like that, or you could have your calculator do a row swap right at the beginning. It doesn't really matter. But let's put this into our calculator and see what we can do. Now I need to ask you an important question. If I show you a shortcut on this, are you still okay showing me all the work, telling me what you do? And we'll come back to that. So let's put this into our calculator. Which one do you want to use? I'll use this one, just so we can practice one command a little bit more. Second, matrix. We want a 3x4. So, yeah, I always do this. You got to go to edit first, and then choose your matrix. So, got a different calculator. I'm going to put this 3x4 here. So 2, -3, -9, -5, 1, 0, 3, 2, -3, 1, -4, and -3. So there's my system of equations. I'll exit out of this and just double check it. I'm going to print matrix B by hitting the second key and the matrix menu. Just type the number 2 and press enter. And that looks pretty good. So let's go into program row ops and see if we can't put this into row echelon form or echelon form. Let's see. So program row ops, select matrix B. And the first thing I promised you I'd do, I would interchange the first 2 rows. So that's going to be a row swap. So here you go. Row swap, row 1, and row 2. And there you go. The nice thing about that is that it puts a 1 in the upper left-hand corner, which is where I want it. Now we're still going to follow through and get zeros in our matrix in the same order we did before. 1, 2, and then 3. Let's see what happens as we do that. So the first thing to do is to get a 0 where that 2 is. I'll multiply row 1 by -2. So that's a row, multiply row add, the 4th command. Multiply row 1 by -2, add it to row 2. Next, I want to multiply row 1 by 3 and add it to row 3 to get rid of the -3. So that's another multiply row add. So type the number 4. Multiply row 1 by 3 and add it to row 3. Okay. Now I'm going to do something right here to make my life easier. I want to get that 1 to be a 0, but I'm going to do it in kind of a different way than you might expect. Did you see how easy it was when I had a 1 up here in a place called the pivot to get the zeros here and here? It'd be easier if I had the 1 where the -3 is. So I'm going to swap those two. So I'm going to do a row swap of rows 2 and 3. Whoops. Wait a minute. Oh, I must have. That's weird. It multiplied the bottom row by -2. I don't understand why it did that. Let's see. I'm going to clean that up and multiply row 3 by -0.5. There we go. I'm not sure what happened there. So let's go back. I want to swap those two. So it's a row swap. First row would be 2 and swap it with 3. There we go. That was weird. I think maybe I should have put my rows in numerical order. In any case, now I'm set up to get rid of the -3 here. I just multiply this by 3 and add it to the third row. So type in number 4, multiply row 2 by 3, and add it to row 3. And bam, that's what we get. You can do all this stuff by hand. You don't have to do it on row ops. The nice thing about row ops, though, is that it's not going to make arithmetic mistakes. And that's going to be the biggest pain if you're doing it by hand. So if you're doing it by hand, you have my condolences ahead of time. This system equation reduces to 1, 0, 3, 2, 0, 1, 5, 3, and 0, 0, 0, 0. Now, if you have a row of zeros, that's telling you that your system of equations is what? Can anyone fill in the right word there? It's dependent. You're not getting one nice solution. You're getting an infinite number of solutions. So what this works out to be is x plus 3z equals 2, y plus 5z equals 3, and that's it. That's all the equations we've got. So if I solve for x here, I get x equals negative 3z plus 2, y equals negative 5z plus 3, and overall my solution in parametric form would be negative 3z plus 2, negative 5z plus 3, and z. And of course, if you needed to or wanted to, you could write it in terms of t's, negative 3t plus 2, negative 5t plus 3, and t. So, nice. If you would have ended up with something like 0, 0, 0, and 8 here, then that would be telling you that it's an inconsistent system. So either way, if you put it in reduced row echelon form, or excuse me, row echelon form, not reduced row echelon form, if you put it in row echelon form, you'll be able to find out if it's dependent or independent. Now, are we good with that example? I got a little bit more to say about it, but let me just finish this program, and let's exit out. Now, if you make a mistake along the way, you can just hit 7, quit to main, and then just start over, because it still has your original matrix in it. So if I go back to matrix B, there it is. There's matrix B. I don't have to re-enter it. It's still there in its original form. But let me exit out of here. You got to press 7 twice to get out of there. And here's a little bonus material for people who are staying on to the end of the video. But the catch is, you still got to show me your work. All right? So, let's see here. If you go to matrix and then to math, I think it's math. Scroll around till you get to the REF menu. Can anyone think what REF stands for? And it's not referee.
Reference.
That's a good guess. It stands for Row Echelon Form. So let's give that a try here. So Row Echelon Form, for me, it was matrix B. So I'll just give it an argument of matrix B. And now it gives me something that is not really that great, which is these fractions.
Oh, no.
But that's okay. If you hit the math key and press enter twice, it'll turn your answers into your decimal values into fractions, if it can. And in this case, it can. So, wow. There's your reduced row echelon form, or your row echelon form. It's not reduced row echelon form, but that's okay. So it's showing you kind of what we got. And let's see, I'm not sure why it's not showing us perfectly what we got. Something about that bothers me, but I'm not going to be able to solve it right now. It's a nice way to double check your work. And I'm telling you about it, so I'm okay with you using it. But don't just give me an answer miraculously and say, hey, look, it's all done. No, I still want to see some of the work. Now, I'm not going to make the work really, really difficult. All right? It's going to be enough that you do something maybe like what we did here. Just list the different commands you use. It's going to be really short and sweet. Okay. I am bothered a little bit about how come I didn't get exactly what I got just a minute ago. I'm going to just take one quick look at this, see if I can't figure it out. 2 -1. Yeah, I'm not seeing exactly what could have gone wrong here, but I am somewhat heartened by the fact that ours matched here, 1, 5, and 3. I think it's just doing something a little different than what we did. That's okay. So, all right, good luck with those. I'll show you more tricks as we move on.